Hi. My project focused on research in Greenland. Greenland ice is super important because it contributes 1/4 of all sea level rise each year. So that's kind of a big deal. The place that I actually focused on for my research was at Helheim Glacier that terminates into Sirmilik Fjord. Helheim Glacier is the 5th largest outlet glacier in Greenland. And it moves pretty quick, and it definitely puts in a lot of water, so it's very interesting to see the processes going on. The parts of a glacier, just for anybody who doesn't have this knowledge, a glacier is pretty much like a river. It's ice and it moves downhill altogether. It breaks off in between the blue part and the white part. It breaks off at the terminus where it calves into the melange. So all this stuff from here all the way over to that blue part is going to be the melange. And that's pretty much a big mixture of icebergs and whatnot that are being pushed back on itself. It doesn't move super fast. It moves a little bit faster than the glacier. And this part right here that it terminates into is going to be the fjord. This is very important for us to look at the terminus retreat at Helheim Glacier, because from 2001 to 2006, it had a massive retreat event that just kept happening. It has since mostly stabled out since 2006. It does still see retreat, but luckily some of the years with the lower, it actually refreezes in the winter to get itself back at the terminus point that it was at the year before. The data that I took for my project was collected at 4 different sites. CREL is actually a camera site up by the terminus that actually points at the terminus. And then MITS, the TAS-L, and the TAS-U, those are all PROM ice automatic weather stations. And those were used for the atmospheric temperature, the wind speed, and atmospheric temperature and wind speed, and wind direction, which we didn't use in this project. These are just kind of a brief overview of what the automatic weather stations look like. I got the sea surface temperature from Landsat 8 from Earth Explorer. So we download all the images that we had. We had 11 different bands for the Landsat 8, and the bands that we used for our processing was 5, 6, and 7. And this is band 10. This is the thermal infrared. This is the one that really, really matters to us. So for this project, I built a land mask, which took out all the parts of the land because we only wanted information for the sea surface temperature on, of course, the water parts of the images. And then we took the subsets, which are the little green boxes on the right. Those are actually to give us averages within the fjord, because a lot of the information that we get when we're doing averages is out here. This stuff doesn't matter too much for the research that we were doing. After we process the imagery, the pictures come out looking like this, which is pretty cool. And I did a red, green, blue background for it to give it kind of a nice, pretty picture. This is the hottest day that we recorded of any of the images. We had about 46 to 50 images. This is the hottest that we recorded of any day for the mean. The mean that I actually put on our slides is 5.96. That was just in those 3 little green boxes, so that way it doesn't account for any of this hot stuff out here. When I saw this picture, it started making me think, like, what's going on in the fjord and at the terminus itself. Luckily, because we had that CREL camera right on the terminus, I got to see this exact day at the terminus. And they actually had a couple different pictures from this day. This day shows right here. This is the same day as that picture before. And this red line shows you where the terminus is. This was taken at 3 a.m. Less than 12 hours later, on the same day with the hottest sea surface temperature, there was a massive calving event. To give you guys some scale on this, the terminus is 6 kilometers across. The actual height here is going to be 100 meters high, so that's very large. I have a better picture at the end of this, but keep that in mind while I go through this. So that was pretty interesting to me to see that we had the highest sea surface temperature and we also had a calving event. So I took the information that we had from the rest of the weather stations that we got, the atmospheric temperature and the wind speed, and we kind of put that all together to see if there was maybe any correlation. We also found there was a couple of other days that we had this, a little bit higher for the month and the days around here. This was a year before that last image was taken. And as you can see, we have another major calving event within 24 hours of each other. And here's the great size reference for you guys. So this is actually Helheim Terminus. This is 100 meters high, and that's a real helicopter. So when you see pictures like this, that's not a little bit of ice that's missing. That's a good portion of ice that we have missing here. Anyway, so with this data, we put it all together onto a map and ran everything to see if there was any connection. Unfortunately, we just didn't have enough data. There was a lot of days that we had the air temperature for and the wind speed for, but we didn't have very much sea surface temperature data. And the calving data came from me actually sitting with the camera and just going every single day. So those are ones and zeros, and they're represented in the red lines here. This is each calving event that happens. The purple is my wind speed, and the blue is my air temperature. We did run this through a couple of things and see that there was a little bit of a correlation here. The p value is greater than the absolute value of z is pretty much saying the lower number that you have here means there's a less chance of it happening by just random chance. So we don't have the sea surface temperature data in this image, and there's a reason for that. The sea surface temperature, although that's what actually brought me to my project and made me looking for these calving events, the sea surface temperature didn't actually correlate well. But we don't know that it doesn't. We only had 5 images that happened on days with calving events, so there's just not enough information. If this process went on much longer, we could definitely probably find a couple of more similarities that we could put together with this. Yeah. Are there any questions?